In part 6 of work, we're going to finish the problem that we had on dealing with a force across a different path where the angles between them or the magnitude of the force changes. So we're going to calculate the work done by a force yi plus 3j on a particle going from A to B, but this time we're going to take a different path than we did in the previous video. The path we're going to take is to go straight up first, and then to go over to B by this path. So this will use parts 3 and 4, which are our straight line paths that we're going to break up the whole problem. So we're going to go up here and over, but we're going to break into two parts, this part and that part, and then we're going to calculate the work for each part and add it together to get the total work. So from y equals 0, 0 to 0, 2, so this is work on 3, we're going to have to put in our equation for work, and for that I need the force, and the force was yi hat plus 3j hat, and then I want to dot that, and here we're not changing the x at all, but we are changing the y by 2 units. Okay, to j hat. And all of this, of course, will give us joules at the end. So this time, y times 0 is 0. 3 times 2 is 6. So W3 is equal to 6 joules. On the horizontal part of the path, we had yi hat plus 3j hat. And we're going to dot that, and this time we're going to change x by 1 unit, but we're not going to change y at all. So 1 I hat plus 0 j hat. So W4 would be equal to y plus 3 times 0. So that's just y. But on this path, which is from here to there, y has a constant value of 2. So therefore, y4 is equal to 2 joules of energy. Y is the total W, is then the work on path 3 plus the work on path 4, and we find it's 6 joules plus 2 joules is equal to 8 joules. Now what's interesting about that is the amount of work doesn't just depend on where you start and end in this case, but it depends on the path you took. If you took the first path we computed, the total work done by the force was 6 joules. If you took the alternative path that you went up first and then over, the work done was 8 joules. That's more than 6, which means that the particle taking the blue path will come in with a faster, higher speed than if they took the first path. Put that in there. Particle taking this path a higher final speed. Than in part A. Work is path dependent. In other words, the value you get, it depends on the path. If the force is non-conservative. There are two different types of forces that we're going to split in as we go on. Those in which the work done from going from A to B is independent of the path that you take. No matter what path you take, no matter how many crazy it may be, there's literally an infinite number of different paths, but you always get the same answer. If that's the case for the work, then you say that that force is conservative. If on the other hand you're like this force, where taking one path gets you 6 joules and the other path gets you 8 joules, then it depends upon the path. So the work is path dependent. We say that that force is a non-conservative force. In this course, at least for right now and through the fall, there are 2 standard conservative forces that we know of. One is gravity and the other is what's called a spring. We will spend some time with those and develop ways to compute their works quicker under what's called potential energy. Alright, that finishes this video.